Hello and welcome to Mr. Tompkins Ed Tech. I recently got this comment from a subscriber asking if I could make a video going over the really tough questions that sometimes get thrown up on exam papers. Well, thank you Constantine M for this suggestion. I thought this was a really good idea and I thought it would be helpful for those students chasing the higher grades. So here's my top 10 toughest questions that have appeared on GCSE maths exams over the last few years. These questions come from AQA, Edexcel and OCR exam papers. I've scoured examiners' reports and statistics and picked out questions from a range of topics that tripped up and defeated all but the most savvy of students. If you find these tough, you're not alone. Most students who are unlucky enough to encounter them in their actual GCSEs left them blank, and those that did give them a go barely got started or took a wrong turn. If you want to give them a go yourself, I've created a worksheet that you can download from the link in the description below the video. You can then watch through my solutions to these trickiest of problems to see how you did and mark your work. If you want to practice these topics further, you'll find links to related resources in the description below the video. Let me know if you agree with my picks in the comments below. If you think you found a harder one, let me know about that one too. Don't forget to like and subscribe if you found this video useful. Good luck in your exams and I'll see you on the next video. Question 26. Zoe and Amy are playing a board game. They each have one disc and take turns to roll a fair ordinary dice. The player moves their disc clockwise the number of spaces shown on the dice, and the winner is the first player whose disc is on home at the end of a turn. Here is the board after Amy's turn. Work out the probability that Zoe wins within her next two turns. Okay, so if Zoe's going to win, what's going to have to happen? Right, well, first off, Zoe could roll 3, couldn't she? She could roll 3 and she could go 1, 2, 3, boom, win. So if she rolls a 3, that is one possibility. She'll just win on her first go. Now, assuming she doesn't do that, are there other ways that she can win? Well, yeah, she could roll a 1 on one go, and then on the next go she could roll 2. So she could roll a 1 and then a 2, or the other way around, she could roll a 2 and then a 1. Okay, are there any other possibilities? What about if she rolled a 6? Could she get all the way back round again? So if she rolled a 6, 1, 2, 3, 4, 5, 6, and then could she get around with another 6? 1, 2, 3, 4, 5, 6. No, she can't, it's too far. Okay, so that is really the only possibilities then, isn't it? Okay, she either rolls a 3, or she rolls a 1 and then a 2, or she rolls a 2 and then a 1. Okay, so what is the probability of that happening then? Okay, well, the probability of rolling a 3 on a dice, there are 6 sides, 1 3, so that's just going to be 1 over 6. And then the probability of rolling a 1 and then a 2, well, the probability of rolling a 1 on the first throw is 1 over 6. And the probability of rolling a 1 on the second throw is 1 over 6. So it's going to be 1 over 6 times 1 over 6. And the same for 2 and 1, isn't it? It's just the same. Probability to get 2 is 1 over 6. Probability to get 1 is 1 over 6. So then her overall probability of winning the game is going to be that probability of 1 in 6 of rolling a 3 plus the 1 over 36 probability of rolling a 1 followed by a 2 plus the probability of rolling a 2 followed by a 1, which is another 1 over 36. Okay, so what does that add up to? Well, 1/6 is the same thing as 6/36, and then if I add on 1/36 and 1/36, that is going to give me 8 over 36, and I think that then is my answer. I could cancel it down, but it's probability. They never give you marks for it. I'm just going to leave it as that. Question 19. ABC is an isosceles triangle. The sides of the triangle ABC are all tangents to a circle of radius 6 centimeters, center O. Angle BAC is 70 degrees and BA equals BC. Show that the length BO is 17.54 centimeters, correct to 2 decimal places. Well, oh my, this is going to be fun, isn't it? Okay, where to start? Well, let's just add on our extra angles. So this is an isosceles triangle, so that one down there is also going to be 70 then, isn't it? Because that's the other base angle of the isosceles triangle, which makes this one at the tip 70 plus 70 is 140. Take away from 180, and that's going to be 40 up there, isn't it? Okay, so I've got 40, 70, and 70 on my diagram. Now this is a show that question, so I feel like we should probably write down the reasoning as we go through when we're finding these angles out then. So I'm saying that ACB, the bottom angle, is equal to CAB, which is equal to 70 degrees because it's an isosceles triangle. And we know that ABC equals 180 degrees minus those two 70-degree angles, which is equal to 40 degrees. And that's because of angles in a triangle sum to 180 degrees. So kind of for each step, I'm just going to give a quick reason for what it is and why it is. Okay, right, so that's the angles in the triangle. What do we actually need to find though? Length BO. Where's BO? Okay, that's not actually marked on the diagram. Let's just draw it in. So BO then is this line here. I'm kind of seeing a triangle in here. Can you see where the angle here is going to be half of that angle at the top, and it's a right angle triangle, and I know one of the sides, so I think I can use trigonometry in here to work out that triangle, to work out the hypotenuse of that side. Then I'm just going to pull the triangle out of my diagram. So in triangle, well, it doesn't have a name, does it, because I don't have a point. Let's call that point there M. So in triangle MBO, okay, let's just draw it. I'm going to take the triangle out and I'm going to draw it on the side. Okay, so that was the right angle. That was 20 degrees at the top, and then that was 6 centimeters, wasn't it? That's B. That's my point M that I wrote down, and that's O. Okay, I'm going to say angle MBO is half of that angle at the top there, which is 20, isn't it? Okay, because basically this line BO is going to bisect this angle in two, isn't it? It's going to cut it in half. Okay, so that's 20 degrees. And then so what we need to do then is to use now trigonometry in this triangle to find the hypotenuse, don't we? This side here is the hypotenuse, this one is opposite the side of the angle, and this one is adjacent. So SOHCAHTOA, which one are we going to use? SOHCAHTOA. Which ratio do we need to use here? Well, we want the opposite. So we've got the opposite, we want the hypotenuse. We're not interested in the adjacent, so any of the ratios that got an A in it we can kind of get rid of. It's just the one there at the front, so that's the one we want. Okay, so then write down the full trigonometric ratio, which is sine theta is equal to op over hype. Okay, and then sub in from my picture. So I know that the angle is 20, so sine 20 degrees is equal to the opposite, which we know is 6, divided by the hypotenuse, which is what we're trying to find. Okay, I'm going to give it a letter, I think. So I'm going to call it x. So over x, because I don't like writing hype down in the form that looks wrong. And then rearranging, we can just cross multiply these, can't we? Just kind of switch them over. You can do it in 2 steps if you find this tricky. X equals 6 over sine 20 degrees. You can multiply through both sides by x and divide through by sine 20 if you're not happy with cross multiplying. And then we've got this thing that we can then type into our calculator. 6 divided by sine 20. So 6 divided by sine 20. I make that, oh look, 17.54. Perfect. Equals 17.54 centimeters to 2 decimal places. Part B says find the area of triangle ABC. You must show your work in. Now to find the area of a triangle we need to know its base and its height, isn't it? So area of a triangle is a half base times height. Do we know either of those things? Well, we just found part of the height, didn't we? So if you remember, we found this distance here, BO, from here to here. Okay, and we found that was 17.54, but we also know what this little bit down here is, because that is the radius of a circle. So BO was 17.54, and that is 6 because it's a radius. So then B all the way down to the bottom, so the height of this triangle then is going to be 17.54 plus 6. So H equals 17.54 plus 6, which I make to be 23.54. Okay, so that's my height. Can I work out the base? Now remember, this angle here was 20 degrees, and if I've got the height, I should be able to work out. So if I know this side here, I should be able to work out half the base anyway, because this is a right angle triangle, isn't it, that I've kind of formed here. So I'm going to use SOHCAHTOA again. I'm going to use, but in a new triangle. So I'm going to do it in a triangle. Now I want to refer to a point that I don't have on my diagram, so I'm just going to add another one in. So I'm going to call this point here N. So in triangle ABN, then what's going on? Well, let's just draw it again. I kind of like to take, if I've got a complicated diagram, I like to take the little bit that I'm looking out so I can kind of draw on it and look at it in isolation from the rest of the diagram. So just quickly drawing that part of the triangle. So I know this is a right angle. This is the point N. This is B up here. This is 20. This is 70 degrees, and this is A. So what's what on this diagram then? Okay, so I need to pick an angle for trigonometry. Let's use the 70 because that's the one that was given to us. I'll use that one down there. Then angles relative to that angle. This one over here is the opposite. This one is the adjacent. This is still the hypotenuse, which is the longest side. Now, right now, our handy mnemonic again, SOHCAHTOA. What we got now? So this time, I know. Oh, sorry, I forgot to write the length on here. This was, we said, was 23.54. So we know the opposite. It's here. Look. What we want this time is the adjacent, isn't it? Okay. I don't want the hypotenuse. Not interested in the hypotenuse. So anything with a h in it, don't care about this time. So it's tan. Tan is what I want. So writing down the full ratio. Tan theta is equal to op over adj. Okay, then what have I got then? So tan theta, tan 70 is equal to the opposite, which we know is 23.54, and we're going to be dividing through by the adjacent, which is what we're going to find. Okay, so I'm going to have to give another letter to my diagram. I'm going to call this side y. Let's call it like that. Tan 70 equals 23.54 over y, and then we're going to rearrange for y then, that side that I want to find. So I'm just going to, again, I need to cross multiply these around. They kind of swap over, and I'm going to get y is equal to 23.54 divided by tan 70. What is that then? Now I've still got my last calculated value stored in the calculator, which is a little bit more accurate than my 23.54, so I'm going to use that instead. I'm going to add 6 to it to get 23.54 and change, and then I'm going to divide it by tan 70. By doing that, you just kind of retain a little bit more accuracy in your work. Not so important for GCSE, but it's good practice for A level. Right, so that comes out to be 8.5688, which I'm going to round off to 8.57, and that's going to be in centimeters, isn't it? Now that isn't quite what we want though, because that's just this distance from here to here then, isn't it? So what we want then is double that. We want to find the base, so the base is going to be all the way across from A through to C. So AC is going to be 8.57 times 2. Again, I'm going to be using my calculator value rather than 8.57. Just going to multiply that up by 2. I get 17.13. So I'm just going to say that's equal to 17.1. Okay, and then that's going to be my base then, isn't it, from my calculation up here. So that's going to be 17.1. Now I know everything I need to find the area of this triangle. So I can say then that the area of the triangle is half base height, which is a half times 23.54 times 17.1. Okay, so what's that? Times 23.54 divided by 2. That comes out to be 201.7. Just going to round it off to 202 centimeters squared. Okay. It's quite long that, wasn't it? Quite tricky. Question 25. Two sides of the triangle are measured to 1 decimal place. The angle between the sides is measured to the nearest degree. Work out the upper bound for the area of the triangle. Okay, so let's say that this is a triangle CAB. So then that is side A and that is side B, and the area of the triangle then is going to be, using the trigonometry formula, it's going to be half AB sine C, isn't it? That's the formula we're going to be using. Okay, but before we use those, we need to work out what our upper and lower bound are for the three lengths A, B, and the angle C. Okay, so let's start with A and B. Now these sides were given to the nearest decimal place. Okay, so what I like to do with these questions is I draw a quick number line. I mark on the value been given. So for A, we're told it was 13.6 to the nearest decimal point. So the next one up on the scale would be 13.7, and the one below would be 13.5. So the values that round to 13.6 are going to be the ones that are kind of halfway between those two or nearer. These are the ones that round to 13.6. So that's going to be 13.55. That's the lower bound, and 13.65 is the upper bound. Okay, so that's the upper bound and lower bound for A. Now B is going to be similar. We've been given it as 7.2. On the number line, one decimal point above that would be 7.3, and one below it would be 7.1. So the halfway values are going to be 7.15 and 7.25. Okay, so that's the range of values for B. And then finally for angle C, that is to the nearest degree, and we've been given it as 110. So 1 degree above would be 111, and 1 degree below would be 109. So the ones that round to 110 are going to be halfway between those or nearer, which is 109.5 and 110.5. Okay. Now, obviously, I want to work out what the upper bound is. So I'm definitely going to need the largest value of A and the largest value of B. That's for certain. I'm not quite sure about the sign, because you know the sign goes up and down in value. So I think I'm going to work out both values using both my endpoints. I'm going to use this one and I'm going to use this one because I'm not quite sure what the effect that the sign is going to have. So I'm going to work out both, and then I can see what's what. But I'm definitely going to use the bigger one for A and B because it's just a straight multiplication for those. So the bigger value of A and the bigger value for B is going to be my bigger value for my area. Okay, so area could be a half times the upper bound, which is 13.65 of A, times the upper bound of B, which is 7.25, times the sine. Well, I don't know. I'm going to try the upper bound, 110.5, and then see what that gives me. And then I'm going to do the same thing. I'm going to work out half 13.65 times 7.25 times the sine of 109.5, and I'm going to see which is the bigger one of those two, and then that is going to be my my answer, and that's going to be my upper bound, isn't it? So let's work those two out. So 0.5 times 13.65 times 7.25 times the sine of 110.5. Now that one comes out to be 46.347. I'm going to round it off to 46.35. Okay, and then the other one, 0.5 times 13.65 times 7.25 times the sine of 109.5. I got a feeling that one's going to be bigger. Yeah, it is 46.64. So spookily, the smaller angle of the two actually delivers the biggest result in it, and it's because the sine goes up and down like this, isn't it? Okay, so you know, just because the angle is bigger doesn't mean that the sine of the angle is bigger, because it oscillates. Okay, so in this case, the sine of the angle ends up being smaller the bigger it is in that range. So yeah, so therefore my upper bound is going to be the bigger one of those two then, isn't it? It's going to be that one there, is 46.64. Question 21. The time period t seconds of a simple pendulum of length L centimeters is given by the formula t equals 2 pi times the root of L over G. Complicated formula, but it's quite a cool formula as well. It's the reason why if you take a pie, I don't know, what, chicken pie, what's your favorite pie, and suspend it on a string which is of length 1/4 of 9.8 meters and swing it, it's going to take exactly pi seconds to swing from one end to the other and back again. So that's pretty amazing, isn't it? But that's a bit of a by the by, a fun experiment if you get bored. But Katie uses a simple pendulum in this experiment to find an estimate of the value of G. Here are her results. So L equals 52, correct to 3 significant figures. T equals 1.45, correct to 3 significant figures. Work out the upper bound and the lower bound for the value of G. Use pi equals 3.142. You must show all your workings. Okay, so actually this question has nothing at all to do with swinging chicken pies, but everything to do with error intervals, isn't it? It's one of those ones where numbers have been rounded off to a certain degree of accuracy, and you need to then work out what the upper and lower bounds are for the outcome. Okay, so let's have a look at the two values we've been given. L, the length of the string, is 52, correct to 3 significant figures. So first significant figure is the 5, the second is the 2, and the third is the 0 there. So that means this number's been rounded off to 1 decimal place. Okay. Now, in order to visualize that, I like to draw a number line, and I mark on my number line the value that they've been given me, which is 52.0. Then I mark on the scale 1 up from that using whatever rounding they've done. So they've rounded off here to 1 decimal place, or to the nearest tenth. So going up a tenth from there is 52.1, and going down a tenth would be 51.9. Okay, so then the values that are going to round to 52.0 are the ones that are halfway between those values or nearer to 52. So this is the magic range here that rounds to 52.0. Okay, what are the values of that then? What are the bounds of that then? The lower bound then is going to be halfway between 51.9 and 52.0. That is going to be 51.95. And then on the other end, what's halfway between 52.0 and 52.1? That's going to be 52.05. Okay, so that's the upper and lower bound for the length of the string, of the pendulum. Then for T, it is 1.45 correct to 3 significant figures. So again, first, second, third significant figure. This time we're rounding off to the nearest hundredths, aren't we? Okay, so put in again the same sort of thing. I'm going to draw a number line. I'm going to mark on the value that it gave us, which is 1.45. I'm going to go up 1/100th above that and mark that on the scale, 1.46. I'm going to go down 1/100th below that. That's 1.44. And then I'm going to think about what numbers are going to round to 1.45. They're going to be the ones that are halfway between or closer, aren't they, to 1.45. So we're talking about this range of values here. Again, what are the upper and lower bounds of that then? Halfway between 1.44 and 1.45, that is 1.445, okay? And halfway between 1.45 and 1.46 is 1.455, okay? So that's my upper and lower bound for t, which is the time period in seconds, okay? So work out the upper and lower bound for the value of g. Use pi to be 3.142. Okay, so this is a formula given in terms of t right now. We need it in terms of g if we're going to be able to do this thing. Okay, so we're going to have to rearrange it first, aren't we? So it's quite a complicated rearrangement, actually. So let's get cracking with that then. So if t is equal to 2 pi root L over g, okay, then we want to try and get g by itself, but first I want to try and get rid of that root sign, because I don't want to be flipping things up and down from numerators to denominators while they're rooted. So let's get rid of the root sign first. But before we can get rid of the root sign, we're going to have to move this 2 pi over the equal sign. Okay, cross multiplying that 2 pi, or dividing both sides by 2 pi if you'd rather, I'm going to get t over 2 pi equals the root of L over g. Okay, next step, square both sides. That's going to get rid of that square root, isn't it? Okay, so that's going to give me t squared over 4 pi squared then. Should I do it like that, or should I just leave it? Maybe I'll just leave it as a... No, I'm going to do it like that. 4 pi squared. And that is equal to L over G. Okay. So now what I'm going to do is I'm going to cross multiply. This G is going to go up here. It's going to switch places with the t squared, which is going to go down here. And this 4 pi squared is going to go up there. Okay. So a little bit complicated, but moving it all around, I'm going to get G then is equal to the 4 pi squared is moving up. So it's 4 pi squared, the L stays where it is, divided by the t squared is moving down. So it's going to be 4 pi squared L over t squared. Okay, so that's what G is in terms of the other things there. Now, 4 and pi and squared, these are all constants, aren't they? Okay, they're not going to change. I'm going to use that throughout. Okay, but for the L and the t squared, I've got different choices that I could put in for those. I've got my upper bound and my lower bound, and I need to think about which one is going to deliver the highest and the lowest possible values for G. Let's consider the smallest possible value of G first. What's the smallest value of G I could get? Now, the smallest value of G I can get would be if I used the smallest possible value of L, so that's going to be 51.95, and divide it by the largest possible value of t, okay, because that's on the bottom. So if you think about a fraction, the bigger the denominator, the smaller the actual size of the fraction is. So subbing those values in, so that's 4 times 3.142 all squared times L, I'm going to use 51.95, the lower bound, divided by the upper bound of t, which is 1.455. Okay, so what does that come out to be? 4 times 3.142 squared times 51.95 divided by, oh, I should have put a square around that, shouldn't I? Divided by 1.455 squared. Okay, now that comes out to be 969. Okay, now I happen to know what gravity is. It should be 9.8 meters per second, and I've got 969. So I had a moment of panic there, but I think probably what's going on is that L, the length of the string, is measured in centimeters rather than meters, and so this is a measurement in centimeters per second rather than in the normal meters per second that gravity is normally measured in. So I think we're good. It's a low measure, but you know, it's our lower bound for G, isn't it? So then upper bound, upper G. What be upper G? Upper G. Now, what is the biggest value of this I'm going to get? Well, the first bit has to stay the same. 4 times 3.142 all squared. No changes there. But for the largest value of G then, what I'm going to do is I'm going to pick the largest possible value for L, 52.05, and divide it by the smallest possible value of T. Okay, and that will give me the largest possible value of G, hopefully. So times by biggest L, 52.05, over smallest possible T, 1.445. What does that give me? 4 times 3.142 squared times 52.05 divided by, oh, I forgot the square again. I'm not very good at putting that square in. Divided by 1.445 squared. Okay. Oh, that comes out to be 984. So that's just a little bit above what I believe true gravity to be. So I'm feeling pretty chipper about those. So I've worked out the upper bound and the lower bound value of G. Good. 969 and 984. Okay, no units given here, so I'm not going to put any in. Question 24. The flight of a plane was in 2 stages. The table shows information about the flight. So the first stage of the journey, the distance travelled was 731 miles, the speed was x, and the time in hours was 731 over x. And then in the second stage, distance was 287, speed was x over x minus 24, and time was 287 over x minus 24. Okay. In total, the flight lasted 2 hours. Work out the value of x. Okay, so most of that table we don't need then, is it? The distance and the speed have been used to calculate the time. Time is equal to distance divided by speed. So you can see the first 2 numbers here and here just end up being here, and same with the second one. Okay, so they've just used kind of the DST triangle to work those out. So actually we don't need to know that bit at the beginning. All we need really is the last column of this table, this bit here. We know that the total, the flight time lasted 2 hours. So what we need to do is to say, well, I've got 731 over x, and I've got 287 over x minus 24. And I know that this is equal to 2 because it's 2 hours. Okay, so what we then need to do is work out what x is from that. So what we've done here is we've formed an equation in x, and this equation so what we've done here is we've formed an equation in x, and that equation involves some algebraic fractions that we're going to have to deal with. Okay. So first off, when you're adding fractions together, you need a common denominator. And we're going to form that common denominator by multiplying x and x minus 2 together. It's a bit like if you had like halves and thirds, then the common denominator would be 2 times 3, it would be 6, wouldn't it? So here I've got x and x minus 24, so the common denominator is x minus 24 in the same way. Okay, so how many times does x go into x times x minus 24? It goes in x minus 24 times. So I'm going to have to take that 731 and multiply it by x minus 24. And then that's going to be added on to, how many times does x minus 24 go into x lots of x minus 24 times? It goes in x times. So that's going to be 287x on the top. Okay. Now, if you find fractions algebraic fractions really difficult to follow, just write some fractions down and have a think about what you do with those. Algebra is just generalized arithmetic, so whatever you do with numbers, you just do the same thing with algebraic terms. So just try that out. All right, so then on the top here, I've got 731 lots of x minus 24. So I'm going to just multiply out that bracket there. So I'm going to get 731 lots of x minus, what's 731 times 24? 731 times 24, that's 17,544. 17,544, okay? And then plus 287x, and that's all over x minus 24, okay? And that's equal to 2, okay? Now the next thing I'm going to do is I'm going to cross multiply this up here, okay? Just multiplying through both sides with x minus 24. So that's 1018x minus 17544, and that is going to be equal to 2 lots of x minus 24. Okay. So then I got to do some FOIL on the, well, then I've got to remove the brackets on the right hand side there, haven't I? So that's going to give me, on the right, I'm going to get 2x squared minus 48x. And on the right, I've still got 1018x minus 17,544. Okay. Now, I want to try and get everything on one side, and it makes sense to collect it on the right-hand side because that's where my 2x squared is positive. So I'm going to subtract 1018x. I'm going to add 17,544 to both sides. So these two things here are going to budge over to the other side, aren't they? They're both going to go over there. So that's going to give me 2x squared. And then I've got minus 48x, and I'm going to be taking away another 1018x. So 48 and 1018 together make 1066. So that's going to be minus 1066x. And then I've got plus 17544, and that's all equal to 0. So now I've got a quadratic, haven't I? Okay. Now notice I've got 2x at the beginning, so I can make things a little bit easier for myself just by dividing through by 2. So that's going to give me x squared minus, what's half of 1066? That's 533, isn't it? So 533x plus half of 17,544. 17,544 divided by 2, that comes out to be 8,772. And that's equal to 0. Okay. Right. So now, ideally, I'd like to be able to factorize this, but I've got a very big number there, haven't I? I've got 8772. So to break 8772 down into all its factor pairs, that's going to be a pain. But I really don't want to do the formula because that's even more of a pain. So how can I make this a little bit easier for myself? Well, I could express 8772 as a product of its prime factors, because I've got a key on my calculator that does that. So 8772 shift fact. So that's 2 squared times 3 times 17 times 43. 2 squared times 3 times 17 times 43. Now this gives me some factor pair choices then, doesn't it, that I can possibly make. So if for instance I picked that 17 in there, that looks about the right sort of size, and I did, well, what's 8772 divided by 17? Then that goes with 516. That's quite close, isn't it, to 533 I'm seeing in the middle. So I'm thinking that's probably my my best bet. So 17 times 516. So if I did 8772 and I wanted to know its factor pairs, then 17 goes with 516. I think that's going to be my choice. So It's positive on the end and negative in the middle. That means my brackets have both got a minus sign in them. One of them is going to be 17 and one is going to be 516. Just double check, does that add up to 533? Yes, it does. So awesome. So x minus 17, x minus 516 seems to work. So then that tells me then, and that's equal to 0. So that means that x is equal to 17 or x is equal to 516. Now, do both those solutions actually work though? Now, if x is 17, if you have a look here, if you have a look at x minus 24, now if x was 17, then x minus 24 would be a negative number, which means our plane would be flying backwards, and that is not a good look for a plane. So I don't think this one is a possible solution. I'm going to say not possible, as x minus 24 is less than 0. Okay, so that one's that's not a possible solution. So the only solution is that one, x is 516. Therefore, x equals 516 what? Miles per hour. Okay, I am done. That was quite hard work. Question 23, ABC is a triangle. D is a point on BC such that angle BAD equals angle DAC, which is equal to x. They've both been marked on there already. Look, you've got one there and you've got one there. So that's been done. Prove that AB over BD is equal to AC over DC. Prove that AB over BD, where's AB? Prove that AB divided by BD is equal to AC divided by DC. Okay, is it? Let's find out. How are we going to do that? Now, really for me, I had to pause the video and think about this one. It's a bit of a toughie. Now, there is a more elegant solution to this problem, but I think most GCSE students would overlook it because it involves a little bit of angle manipulation that would probably go over most students' heads, to be fair. I'm gonna do it just using the sine rule 3 times first, and then I'm going to show you an alternative solution that uses this angle manipulation idea, which I think some of you might appreciate. It's certainly shorter than the initial method that I'm going to show you, but like I say, my honest opinion is that most students would have overlooked it in the exam. So hold on to your hats, because we're going to do the sine rule 3 times over in order to crack this baby. Right, then let's start with triangle ABD to start with. In triangle ABD, can you see triangle ABD? It's this one inside this triangle here. Okay, so we're going to apply the sine rule here. So the sine rule says A over sine A equals B over sine B is equal to C over sine C. Okay, so basically the side over its opposite sine angle is equal to a side over its opposite sine angle, isn't it? So I can use that to say that my side BD over the sine of the angle opposite it, which is x in this case, so BD over sine x is equal to AD over sine B. Okay, so the reason I picked this one out is because this side here is shared. AD is shared between the two triangles. Okay, so I'm interested in finding AD in 2 different ways. Okay, actually I could then rearrange this to get AD in terms of the other things. So cross multiplying the sine B, that tells me that AD is equal to BD sine B over sine x. Okay, right, so that I'm done with triangle ABC now, ABD now. Let's switch. Let's look at a different triangle. Let's look instead at this triangle here, this side of the triangle. Again, I'm going to use the sine rule, and I'm going to make sure I use the sine AD because that's the one I have in common. So I can say that in triangle ADC, then what have we got? CD over sine x is equal to AD over sine C. Okay, so again I'm going to rearrange that to make it in terms of AD, because that's the thing they have in common, isn't it? So AD, then cross multiplying that sine C underneath the AD, that tells me that AD is equal to CD sine C over sine X. Okay, now you might have noticed I've now found AD in two different ways from two different triangles, but they're the same AD because they're shared between those two triangles. So that means I can stick those together, can't I? If AD is equal to BD sine B over sine X and AD is equal to CD sine C over sine X, then those two things must be the same. Okay, so bringing those together, then I can say that then AD is equal to BD sine B over sine X, but it's also equal to CD sine C over sine X. Okay, so hopefully that makes sense. I'm actually going to leave the AD bit out because I'm just going to say that those two parts are equal to each other. Okay, so you might notice that they share a sine X on the bottom, so multiplying both sides through by sine X, they're actually going to disappear, those two things. They cancel each other out. So I'm left with BD sine B is equal to CD sine C. Now I'm going to rearrange that. I'm going to rearrange it so I've got the sines on one side and the sides on the other. So I'm going to say that sine B over sine C is equal to CD over BD. Okay, and I'm just going to leave it there for now. I'm just going to let that hang for a bit, and I'm going to look at the third triangle that I can look at. Okay, so now I'm going to switch and I'm going to say in triangle, which other triangle can I use? I can use the whole thing. I can use the whole thing. So I'm looking at triangle ABC now. In triangle ABC. Okay, so what can I do in triangle ABC? I can say that AB over sine C is equal to AC over sine B. Okay, now the reason I wanted that is because I had sine B over sine C in the other one. So if I rearrange this, cross multiply, basically just switch these two around, okay, I'm going to get sine B, therefore sine B over sine C is equal to AC over AB. Okay, so notice over here, look, I had sine B over sine C, and now I've got sine B over sine C over here as well. So I can then bring those two things together. So if I call this one equation 1 and this one equation 2, I can say substitute in equation 2 into equation 1, we're going to get AC over AB is equal to CD over BD. Now it's not quite what I wanted, can you see, but it's got all the right bits. Okay, now this one has got AB on the top and currently my AB is on the bottom, so I want to cross multiply that over to the other side, but also I've got DC on the top where it needs to be on the bottom, so I'm just going to cross multiply those two. Okay, I'm going to switch these two around, and I'm going to say then that AC over, well, I wrote CD, they've got DC in there, so I'm just going to rewrite those letters as DC rather than CD, doesn't matter which way around I write them, and that is equal to AB over BD. Okay, And that's what we've got over here. AB over BD is equal to AC over DC. Okay, so that was fairly hideous, but we kind of got there in the end. I mean, maybe I'll just divide this up so it's a little bit kind of clearer to understand. So I kind of did this step first, then I did this step, then I did this step, then I did this step, and then I did this step. Okay, so yes, it was long and it involved the sine rules in 3 different ways, but finally what we wanted dropped out the other side, so I'm happy. Okay, so if you didn't like the 3 times sine rule way, this is the alternative solution then. So I'm going to go run through the same problem again, but doing it a slightly different way. Now this method involves kind of the relationship between this angle and this angle, and in particular the sine of those 2 angles. We'll come back and look at that in a minute. So if you remember, we were looking at the ratio of AB over BD, which is this side over this side, compared to AC over DC, which is this side over this side. Okay, now you might notice that one of those sides is opposite the given angle there, and so is this one. This one is also opposite the given angle there. Okay, and the other side is opposite this angle down here, D, and the other one is opposite this side of angle D. Now there are different angles, okay, but they're kind of related to each other because they lie on a straight line, don't they? Okay, now if we use the sine rule in triangle ABD first. So again, in triangle ABD, I'm going to use the sine rule for those 2 sides that we want to find, AB and BD. Okay, so side AB over the angle, what's the angle? This one here, isn't it? I'm going to call it D dash. Okay, so AB over the sine of D dash is equal to the other side, BD over the sine of X. Okay, then I'm going to rearrange that so I've got, so it's in the form of what's on the left there, AB over BD. Okay, so I can do that by cross multiplying these 2 things. Okay, so moving one up and moving one down. So I'm going to get AB over BD is equal to sine D dash over sine X. Okay, so that's in triangle ABD. Now let's switch to the other triangle, triangle ACD. So in triangle ACD. Okay, now I'm going to do the same thing. I'm going to use the sine rule to find with those 2 green lines there. So first off, I've got the one opposite angle D, which this time I'm going to call D double dash, just to distinguish it between the littler version of angle D. Okay, so the side AC over the sine of D dash dash double dash, that is equal to my other side, DC over sine of X. Okay, right, so again I'm going to make it look like this bit over here, AC over DC, by cross multiplying these 2 things again. I'm going to move that up there and I'm going to move one down there. Okay, and then it will look like this thing on the left here. Okay, so let's do that. So then AC over DC is equal to sine D double dash over sine X. Okay, so note that we've got the bit on the left of what we want to find up here and the bit on the right of what we want to find down here. And also notice what we've got over here. We've got sine X and sine X that are the same, and we've got sine D dash and sine D double dash, which are not the same because they are different angles. Or are they? Now, if you get your calculator out, let's say d dash, I don't know what d dash is, but let's say d dash was 30, then d double dash would be 180 minus 30, wouldn't it? It'd be because they're lying on a straight line, and so that would be 150, wouldn't it? Now, if I worked out what the sine of 30 was, sine 30, just tap it into your calculator. Sine 30 equals, well, you should know that anyway because it's one of the given angles. It is a half, isn't it? So the sine of 30 is a half. But maybe you don't know what the sine of 150 is. So if I type in sine 150, you'll see that's also a half. So those two sines are actually equal to each other. So the sine of 150 is also a half. So the sine of 30 is the same thing as the sine of 150. Now, is that a coincidence because I happen to pick 30? Now, you can actually try this with any angle. If you make angle d dash any size and then make d double dash 180 minus that side, you'll find that you always get the same sign when you take the sine of those numbers. And the reason for that is, if you look at the graph of sine x, okay, sine x is a nice sine curve, isn't it? It goes up, goes down, goes up again, okay, so that's in 360 degrees, isn't it? So that's 0, that's 180, that's 360, in the middle there, that's 90, and that is 270, isn't it? Okay, now if you pick any number on our scale here on the left hand side for the sine of x and read across to your curve, you'll find that you get one solution down here and a kind of a matching another second solution over here, and these two numbers are always related to each other. If you can see that this curve has got a line of symmetry passing through 90, okay, so whatever this angle is on the left, let's say it is alpha, then this angle on the right is going to necessarily be 180 minus alpha. Okay, so the sine of alpha and the sine of 180 minus alpha always give you the same answer. Okay, and because as angle D plus D double dash is equal to 180, then the sine of D dash is equal to the sine of D double dash. Okay, this is always the case, okay, just necessarily because of the way that sine works, which means that these two expressions here, this one and this one, are actually identical, aren't they? So if these two things are equal, then these two things here must also be equal because they're equal to each other, aren't they? Okay, so then I can say, therefore, AB over BD is equal to AC over DC as required. Okay, now like I say, I don't know how many students would actually have spotted this rule here. It's a little bit off-piste if you ask me. I think it's a little bit cheeky actually to have this in the exam. I think if you were doing further maths GCSE, you're more likely to know that and spot it, but you'd be forgiven not to know it in the exam, I think. So I've given you two different alternative ways of solving this problem, one with and one without that little extra piece of info. So anyway, you can decide which way you'd prefer to tackle. Question 29. A, B and C are 3 points on the circumference of a circle centre O. BD and CD are tangents to the circle. ABDC is a kite. Angle BDC is equal to x. Prove that angle ABO is equal to 45 minus x over 4. Okay. Right, now, there's a lot of blurb about the diagram. I'm quite particular. I like to go through all of this and just double check it's on the diagram because not always so. So BD and CD are tangents to the circle. Okay, so what does that mean? Okay, so we've got BD, these are tangents here, look. Okay, that means that that angle there must be a right angle, and that angle there must be a right angle because of tangents are perpendicular to radiuses drawn at the point of contact. Okay, and then I've got ABDC is a kite. Now that means that that side and that side are equal in length, and that one are as well. Okay, so that also means that we can, well, I don't know what it means. Let's find out what it means in a bit. And finally, angle BDC is X. Now that has been marked on the diagram. Now we want to prove that angle ABO is something. Where is ABO? ABO is that angle there. Okay, so eventually we want to find that. Okay, now with most of these problems though, that is not your starting point. Okay, your starting point is going to be a long way away from that. Okay, all right, so what can we start with? I would start with the things that we know about. So I actually know about this angle here, X. Now I know that X, and I said earlier that I put two right angles on. I suppose we should, if we're going to prove it, we need to write that down. Okay, I'm going to say that OBD and OCD are right angles, and the reason I know that, because I'm going to give reasons for everything, is tangents are perpendicular to radius drawn at point of contact. Okay, so it's good to write down the reasons. Okay, so I know that they're right angles, and I know that OBDC is a quadrilateral. So its angles sum to 360 degrees. Okay, so I know X, I know 90, but I don't know BOC. So angle BOC, that's got to be equal to 360. Okay, so I know that 90 and 90 is 180. And I take that away from 360, that's going to leave me with 180. So angle BOC then is going to be 180 minus X, just simplifying that down a little bit. Okay, so I know that that angle there is 180 minus X. Now I also can see that that is the angle at the center, and this one here is the angle at the circumference, isn't it? Okay, so I know that these two are related. I'm going to use the fact then that CAB is going to be a half of angle BOC, which is a half of 180 minus X. Okay, which is multiplying out the brackets, that's 90 minus X over 2. Okay, I've kind of got halfway then, isn't it? I've kind of got halfway to where I need to get to. So CAB is equal to 90 minus X over 2, and the reason for that is that angle at the center is twice the angle at circumference. Okay, so that's that. So now I know that that must be 90 minus X over 2. So then how can I find that one over there then? Well, I suppose it's got to do with the fact that ABDC is a kite, because that means that that angle and that angle are equal to each other, and we can use the angles inside the kite add up to 360 to take away the two ends and then divide it out between those two angles then, can't I? So I can say that in kite ABDC. Okay, so I know the two ends, don't I? X and 90 minus x over 2. Then so I can say that ABD, angle ABD, is equal to angle ACD because it's a kite, and angle ABD plus ACD plus CAB plus BDC must be 360 because it's a kite. It's a quadrilateral, isn't it? Okay, so what do we know there? ABD we said was 90 minus x over 2. That's ACD is equal to ABD. So I'm going to just replace that as two lots of ACD then, because they're both the same. And then BDC I know is x, and that's all equal to 360. Just going to scroll this up a little bit because I'm running out of space. Okay, so what now then? So I've got 90 minus x over 2 plus x, so that's going to be 2ACD plus 90. So minus x over 2 plus x is just going to be plus x over 2, and that's equal to 360. So taking 90 away from both sides, and the x over 2 away from both sides, I'm going to get 2ACD is equal to 360 minus 90 is 270 minus x over 2, and then dividing it by 2 then ACD, just one lot of ACD, is just going to be half of 270, which is 135, minus half of x over 2, which is x over 4. Okay, but if you remember, ACD is equal to OBD plus ABO. Okay, so our 135 minus x over 4 is going to be equal to OBD, which was a right angle, 90, plus ABO, which is the thing we're trying to find, isn't it? ABO. Okay, so then taking 90 away from both sides, that is going to give me 45 minus x over 4 is equal to ABO then. Okay. Okay, so that was quite a long proof, but prove it we did. Okay, so very good. So ABO is 45 minus x over 4. So just running through that again from the top, we used the fact that tangents and radius is at right angles to find those right angles. Then we used the quadrilateral OBDC to find the angle at the center, and then once we had the angle at the center, we found the angle at the circumference, that's at A, and then we used the kite to find ABD, and then we took away 90 and we found ABO. Awesome, good job. Let's move on. Anyway, question 11. In a class of 30 students, 17 study French, 20 study German, 2 do not study either subject. Complete the Venn diagram. Okay, well the 2's already on there, isn't it? I can see it down there, so that one's already been done. We need to put in the French and German students. Now the problem here is we don't know how many are in the overlap. Okay, so I'm going to start off by saying in the overlap there are X students. So then if there are 17 students studying French altogether, then there must be 17 minus X studying French only. And if there are 20 students studying German and X study both, there must be 20 minus X studying German only. Okay, so now we've got an expression in each of the 4 regions of our Venn diagram. we can equate that with the total number of students in the class. We know there are 30 altogether. Okay, so doing a little bit of algebra, we can say that the number in the first zone, 17 minus x, plus the x, plus the 20 minus x, plus the 2, so they're the things in all four regions, added together must be equal to the 30 students we've got all together. Okay, so then it's just a matter of collecting like terms and solving for x, then, isn't it? So I've got like 17, 20 and 2, so that adds up to 22, 32, 39, so I've got 39. Okay, and then for x I've got minus x, x and minus x, that adds up to minus x. Okay, and then that is equal to 30. Okay, I don't like the fact I've got a minus x there. I'm going to add x to both sides so it disappears from there being negative and re-emerges on the other side being positive. Okay, and then I can subtract 30 from both sides, and that will cancel there and there, leaving me with x on the right, and 39 take away 30 is 9. Okay, so now I know that x is 9, I can fill that in the middle, and then I can work out what the other two must have been then. So 17 minus x, 17 minus 9, that leaves me 8 there who studied French only, and 20 minus 9 is 11. And if you double check, you should find that all those numbers add up to 30. 8, 9 is 17 plus 11 is 28 plus 2 is 30, so it all works. Okay? Right, and then part B says 2 of the 30 students are chosen at random. Calculate the probability that one of these two students studies French but not German, and the other studies German but not French. You must show you're working. Okay, I need more space. Okay, let's see if I can leave the Venn diagram up, but show enough space. 5 marks for this, so yeah, quite a bit of working to do. So 2 of the 30 students chosen at random. Now, if I was going to draw a full probability tree, there'd be like 4 branches, wouldn't there? There'd be like French only, German only, French, German, none. Or neither. Okay, and then again there's going to be like 4 branches after this as well, but that's kind of long, and I don't need all that information. I'm not actually interested in this bit down here. I'm just interested in the French only and the German only branches, and then after that I'm only kind of interested in the 2 branches of the things I'm going to look at. Okay, so again, French only and German only and French only and German only here. Okay, so then if I want to have one of each, okay, 1 French only, 1 German only, I could get French only on the first go, and then I'd have to go German only after that, wouldn't I? Or I could go German only first and then French only. So they're the 2 routes through that I would need to have. Okay, so what is the probability then of French only and then German only? That's going to be equal. What's the probability of going down that branch there? Well, on the first selection, you've got 30 people to pick from, and there are 8 in the French only region. So that would be like 8 out of 30, wouldn't it? Okay, so 8 out of 30. And then in the second selection, if I've already picked 1, so I've only got 29 left to pick from. I haven't picked anyone yet from the German only region, so there must still be 11. So that would be 11 over 29 then, wouldn't it? Okay, and then for the other route, that's the probability of German only and then French only. So that's going the green route. So if I went the green route, German only on the first selection, I've got 30 students to pick, and I have got 11 German students, haven't I? So that would be 11 out of 30. And then on the second selection, French only, I've still got all my 8 French only students, but now I've only got 29 to pick from. So that's going to be 8 over 29. Okay, so then 8/30 times 11/29, that comes to 44 over 435. Okay, and then the other one's going to be the same, isn't it? Because the numerators are both the same, they're just inverted, they're just swapped around, aren't they? So that's going to be another 44 over 435. Okay, so then the probability then, 1 French only, 1 German only, that's going to be the 2 added together, isn't it? It's going to be the 44 over 435 plus the 44 over 435, which comes to 88 over 435, and that's going to be my final answer, 88 over 435. Okay, so like I say, there should be more branches to this. There should be another 2 there, and there should be another 2 there, but I'm kind of just ignoring them because I don't need that information. I'm just concentrating on the part of the diagram I do need, otherwise I'd be here all day drawing a massive spidery thing. Okay, and I don't want to do that. Right, I want to move on and do the rest of the paper. Let's move on and do the rest of the paper. Question 27. Here is a quadrilateral PQRS. We're told that P to S is the vector A, S to R is the vector B, and R to Q is the vector C. They're already marked on the diagram. And then it goes on to say that X is a point on PS where P to X to S is 1 to 2. Y is the point on RQ where R to Y, Y to Q is 2 to 1. Is XY parallel to PQ? Show your working to support your answer. Okay, so let's have a look at this second diagram. X is a point on P to S where P to X to R, X to S is 1 to 2. That means that for every 1 you've got here, you've got 2 here. In other words, the distance from P to X is 1/3 of the distance from P to S. So from that I can know that the vector P to X is 1/3 of the distance of P to S, and I know that P to S is the vector A, so then that is 1/3 of A. Okay, so P to X is 1/3 of A. Similarly, I can say that if R to Y, Y to Q is in a ratio of 2 to 1, then R to Y, vector R to Y, is going to be 2/3 of the vector of R to Q. We know that the vector R to Q is C, so that's going to be 2/3 of C. Okay, now how does that help us? Well, is X to Y parallel to P to Q? Well, X to Y hasn't been marked, so let's just draw it on. That's X to Y. So what we want to know is that line parallel to that one or not? Okay. Now the way we can do that is we can find the vectors X to Y and compare it to the vector P to Q. Now if they are parallel, then they're either going to be the same vector or one is going to be a scalar multiple of the other. Okay, and that means that they have the same direction, even if they have one is a multiple of the other in terms of its length. So we're going to find X to Y and we're going to find P to Q in terms of the vectors that we know. Okay, now first off, let's do P to Q because that's the easy one. P to Q. Now you might think I can just get to P to Q down here. That's what I'm trying to find, but I don't know anything about that route. Okay, all the vectors I've been given are along the other route, so from here to here, from here to here, from here to here. Okay, so we have to use the routes that we know when we're using vectors. So P to Q is the same thing as P to S plus S to R plus r to q. Okay, in other words, it is a plus b plus c. That's my vector p to q. Okay, now my vector x to y, that is going to be x to s. I'm going to do a similar thing. I'm going to go from x up to s, down to r, down to y. Okay, so I'm going to say x to s plus s to r plus r to y. Okay, so x to s is going to be, what did we say it was? X to s. Oh, well, we did the other way around. We did p to x, didn't we? So I found the wrong thing earlier. Well, I found p to x, but actually I wanted x to s. But it's a similar thing. Rather than p to x being a third of p to s, x to s is going to be 2/3 of p to s, isn't it? Okay, so I'm just going to change this one. I'm going to say that vector x to s is 2/3 of p to s, which is 2/3 of vector a. Okay, and then so x to s, that's 2/3 of a plus s to r, which we know is vector b, plus r to y, which is 2/3 of vector c. Okay, so are they parallel? Well, clearly they're not. Okay, now if I had 2/3 of b as well, if I had 2/3 of a plus 2/3 of b plus 2/3 of c, I could factorize out 2/3, and I have 2/3 of a plus b plus c, but I do not. Okay, I've got the coefficient of b is not the same as coefficient of 2/3 of a and c, and therefore they are not going to be parallel. So I can say that vector x to y is not some multiple of vector p to q, and therefore they are not parallel. Question 21. The diagram shows 3 circles, each of radius 4 centimeters. The center of the circles are A, B, and C, such that A, B, and C are a straight line, and AB equals BC equals 4 centimeters. Work out the total area of the 2 shaded regions. Give your answer in terms of pi. Okay. Now, first off, this is a horrendous question. Edexcel have a habit of putting in a very hard question somewhere in their sets of papers. Now it's worth 5 marks, but you have to bear in mind that most people aren't going to get any of these marks, and if you get any of them at all, then you are kind of above the curve. These sorts of questions are really there to kind of decide between the grade 9 and grade 8 students. If you're not aiming for grade 9 or grade 8, then you wouldn't stress too much about these sort of end questions at the end that are super hard. But obviously, if you can score some points, any points off them at all, then you're moving in the right direction for the grade that you're going to get. I always think they're worth a go, but then again, if you come across something like this at the end of the paper and your mind just goes blank, then I wouldn't stress overly about it. Like I say, this is just a question to decide if students are going to get a grade 8 or a grade 9. It's only really for grade 9 students who should really try and get as many points of this as possible. And also, you can get a grade 9 even if you got 0 on this question, if you did well on all the other questions. Okay, it's a hard question. We're going to give it a go. But yeah, if you encounter one like this in the wild, then just give it a go and don't stress too much if you can't solve it all the way through. That's my advice. But anyway, I'm going to show you the solution. Now, I'm going to get a ruler out and add some more lines in here because at the moment it's not very clear what's going on. Okay, now we want to find the area of that shaded region. But what is that shaded region and how does it relate to the circles? I think what I'm going to do is I'm going to add some extra lines on here. Okay, just to give you a bit of a clearer picture of what's going on. Okay, if I draw a line like that and like that, you can see I've got a triangle. I don't know what sort of triangle it is. Okay, can you think about what sort of triangle this is? Let's start off with there. Let's just have a quick look at that triangle. Now, this line here from A to the edge, that is the radius of the circle, isn't it? Okay, because A is the center and that point up there is on the edge, and so is this. This is another radius. Okay, so those two are the same length. So I could say that that side there is equal to that one. Okay, but also this side here, look, this is also a radius. It's the radius of B to the edge. Okay, and because all these three circles are the same size, then that means that is the same length as well. So what we've got here is an equilateral triangle. Okay, so that's an equilateral triangle. And I could do the same thing down here as well. If I put another point down here, I could make another equilateral triangle down here. Okay. Now I could do the same over on the other side. I could make two other equilateral triangles over here as well. Draw those in quickly. Okay, so I've got 1, 2, 3, 4. I've got 1, 2, 3, 4 equilateral triangles. Okay, now if I wanted to find the shaded area, in that case then, I could find the area of the circle B, which would be everything inside the circle, and then I would have to subtract those 4 equilateral triangles, and that would give me mostly B, but I've got some extra bits as well that I would then need to subtract as well. I've got like these parts here, haven't I? Like that part there, that part there, that part there, that part there. Now hopefully you can see that all of these are the same size. They're all kind of like a segment on the edge of the circle, okay? And they're all kind of equal to each other. So what I would need to do is I would find to find the shaded area, it's going to be the area of the circle, and it's going to be minus 4 lots of those triangles, isn't it? 4 lots of the equilateral triangle. So I'm going to have to take off 4 of the triangles, and I'm going to have to take off 8 of those segments. Okay, that's what I need to do. So in order to work out the shaded part, I need to work out those 3 things. The area of the circle, which is easy, that's just pi r squared. And then I need to work out the area of one of those triangles and times it by 4. And I need to find the area of one of those segments and times it by 8. And then if I subtract that all the way from the circle, I'm going to get the shaded area left. Okay, so that's what we're going to do. We're going to work out the triangle, and we're going to work out that segment, and then we're going to do the subtraction, and then we're going to have the answer. All right, so let's do that in parts then. So let's work out the circle first. Start on a easy thing. Circle area is going to be pi r squared. Okay, so the radius we're told is 4. Okay, so that's going to be pi lots of 4 squared, which is equal to, it's going to be equal to 16 pi. I'm just going to leave it in terms of pi for now. Okay, right, so that's that. Now, what about the triangle? Now, area of a triangle, that is going to be, well, it's an equilateral triangle, isn't it? Which means it has like an angle there of 60. So how can we work out, and I know that the radius is 4, that's 4 and that's 4. So I've got 2 sides and the included angle. So I could use like the trig formula for area to work out the area of that triangle. Do you remember what it is? It's half AB sine C, isn't it? Okay. So what's that then? So that's going to be a half. A and B are just the radius, isn't it? So it's half 4, 4, and then sine 60. Okay. Now this is the non-calculator paper, but luckily sine 60 is one of the angles that you need to know from your table of angles that you should have committed to memory. And I know that sine 60 is just root 3 over 2. Okay. And that's equal to 16 over 2 times root 3 over 2. Okay, so then dividing 2 times 2, 4 into 16, that's going to give me 4 root 3 for the area of the triangle. But what about the area of those green bits then, those areas of their segments? What am I going to do with those? Okay, well, let's have a think about what a segment is. So if you think about it, what I've got is I've got a sector of a circle like this, but then I'm taking a triangle away and it leaves me with the segment, doesn't it? So if I've got like a 60-degree angle here and I've got a sector, okay, and then I subtract the triangle part, it should leave me with the green part at the end. Does that make sense? So I know how to find the sector of a circle. So an area of a sector, because that's just minus theta triangle over 360 root 3, and then therefore that's the area of my segment, then, isn't it? So area of a sector is that. So I know the angle in the center is 60, so it's 63/60ths of pi times 4 squared. Just move this over a little bit to give myself a bit more room there. So that's 1/6 pi over 3 minus the area of the triangle, which we worked out to be pi over 6, then, isn't it? Okay. So that's 16 pi over 6. Right, now we've got all the bits. 16 pi over 6, which is the same thing as 8 pi over 3. So the area of the sector is 8 pi over 3. But then, then the area of the segment is going to be then the area of the sector, just moving over a little bit to give myself a bit more space, minus the area of the triangle, which was 4 root 3, then gives me the area of the segment. So the area of the segment is 8 pi over 3 minus 4 root 3. Okay, right, so now we've got all the bits, don't we? We've got the area of the circle, which we worked out to be 16 pi. We've got the area of the triangle, which we've now worked out to be 4 root 3. And we've got the area of the segment. So we've worked out that to be 8 pi over 3 minus 4 root 3. Okay, so then we just need to string it all together. So now we can say that the shaded area is going to be the 16 pi from the area of the circle, isn't it? Okay, and then minus 4 lots of the area of the triangle, which is 4 root 3, and then we're going to minus 8 lots of the area of the segment, which is 8 pi over 3 minus 4 root 3 then, okay? And that came from the purpley bit over there, didn't it? Okay, that's where all the bits came from. So now it's just a matter of multiplying it all out and tidying it all up, and then hoping we don't drop anything along the way. All right, so I've got 16 pi, nothing to do there. Multiplying out that bracket, 4 lots of 4 root 3, well that's going to be 16 root 3, okay? And then the second bracket, minus 8 lots of 8 pi over 3, that's going to give me minus 64 pi over 3, and minus 8 times minus 4 root 3, that's going to be positive 32 root 3, okay? So you can see now we've got two terms. We've got terms in pi, 16 pi and minus 64 pi, and we got two terms in root 3. I've got minus 16 root 3 and 32 root 3. Now, it looks to me like the pi part's going to be negative, so I'm going to write the root 3 parts first. So 32 root 3 minus 16 root 3, well, 32 lots of something minus 16 lots of that something is going to give you 16 lots of that something. So that's going to give me 16 root 3 from combining the two green bits together. And then I've got 16 pi minus 64 over 3 lots of pi. Now 16 pi, if you think about it, is 48 over 3 lots of pi. So if I just rewrite this as times that by 3, I'm going to get 48 over 3 lots of pi then, isn't it, as a fraction. And then 48 over 3 subtracts 64 over 3. Going to subtract the numerators, 48 minus 64. They've got a difference of 16, haven't they? So that's going to be minus 16 pi over 3. Okay, so that's the bits I got from the yellow bits there. Okay, so that was quite horrendous. So that was a fairly hefty question, and I doubt that many students would have worked that through to a full solution under exam conditions. I don't reckon many people have done that at all. But, you know, you could have scored marks for parts of it. You know, working out the area of the circle was probably worth a mark. Spotting that it was an equilateral triangle and working the area of that out would be worth marks. So, you know, even if you don't get to a full solution, as long as you're kind of thinking it through, if you manage to think any of part of it through and write any of it down, you know, you might find that you score 2-3 marks on these sorts of questions, even if you can't get it all the way through to a solution. So always worth giving them a go, always worth trying it out, always trying to see if you can break the problem down and do part of it, even if you can't do the whole thing, but not to get too stressed in an exam situation when you come across Edexcel's rock hard question at the end of one of the papers. Okay, what you don't want it to do is let it throw you off your game. You know, because you should really expect there's going to be a tough one at the end at some point in the Edexcel papers. It's because it's what they do. Okay, yeah, and barely anybody's going to get those marks. That's the other thing to remember. But anyway, if you wanted all the marks, that's how you get. Question 26. Helena ran an 800-meter race in 140 seconds. The speed time graph represents the first 100 seconds of her run. Helena ran the last 40 seconds with a constant deceleration. Work out her speed as she finished the race. Okay. Now, I've seen quite a few students just assume that line, because it's a constant deceleration and it's the end of the race, they assume that it's going to go like that. So it's going to run down and hit to 140 at 0. But she's not going to be finishing the race at 0 meters per second. Otherwise, she'd never get there. You know, she really slowed off that far. She's never going to actually get there, is she? But we actually need to find the speed that she finishes the race. We can't just assume that she finishes at speed 0, just kind of slows right down and just kind of crosses the line at a snail's pace. That's not what happens. It's going to be more like this. So she's going to constantly decelerate, and we need to find the level at which the speed she's going to be at the point where she finishes the race. Okay. Now, the way we can do that is the fact that we know that it was an 800-meter race. So we know the distance traveled, and we know that the distance traveled is the area under a speed time graph. Okay. Now, we've got 2/3 of the speed time graph already drawn. It's kind of in 3 sections, isn't it? It's this section here where she had her initial acceleration from the start. So she was starting from standstill and kind of zoomed off. Okay, so we can work out the area of that little triangle bit. Then she's got that period of constant speed that she's running, which is a rectangle. So it should be fairly easy to work out that area. And then if I take that away from 800, then I should be able to work out the area of what is going to be a trapezium at the end. And then we can find out maybe the height of the trapezium after that. Okay, so what is the area of this section here then? So that one is area 1. So area 1 is a triangle, so half base height, which is the half of the base, which is 10, the distance from there to there, and a height of 6. So half times 10 times 6, that's 30. So 30 meters was traveled in that little triangle bit. Then the next section, this bit here then, it's going to be my area 2. That's a rectangle, so it has formula length times width. The length is the distance from 10, or the time from 10 to 100, so that's 90. And the height is just 6, isn't it? So 90 times 6. So what's 90 times 6? 90 times 6, that's 540 meters. Okay? So altogether, from section 1 and 2, she's done 540 plus 30. So the remainder, area 3, is going to be the 800 meters, the entire length, minus those two, isn't it? It's going to be minus 540 and 30. Okay, so we know then that the area of the trapezium is going to have to be 800 take away 570, which is 230, isn't it? Okay, so the area of the trapezium has to be 230. Now, we know some things about the trapezium, and we don't know one thing about the trapezium, which is the length of one of the sides, don't we? So if we think about what we know about the trapezium, we've got like one side which we know is like the equivalent of this side here, which is going to be a height of 6. We know the length, that distance there is actually the height of the trapezium, because there's a trapezium on its side. That's going to be 40. We don't know this. This is what we're trying to find. This is x, okay, and then it's going to come down like that. And we know that the area inside it has to be 230, okay? So given that the area of a trapezium is half a plus b h, where a and b is our two parallel sides, we know that that is equal to a half times, well, our unknown value x plus the 6 plus the distance between them, which is 40. Okay, so that comes out to be half of 40 is 20, so that's going to be 20x plus 6 lots of 20s plus 120. Okay, so, and we know that's equal to 230, so we can form an equation in x to solve then. So if 20x plus 120 is equal to 230, so taking 120 away from both sides, that means 20x equals 110. So then x is going to be 110 divided by 20. So 110 divided by 20, that's 5.5, isn't it? Okay, so x is 5.5. Okay, so she's going to be finishing the race at x equals 5.5 meters per second. Okay, so in order to finish off, if you wanted to finish this this trapezium off, then it's actually going to finish at that height then, isn't it? It's going to just be like, she's just falling off a little bit in speed. You know, she's trying to win the race. She's just tiring a little bit, but she still wants to win. So, you know, she's not going to end at a crawl, is she? So it's going to end up looking like that with an area of 230 then, isn't it, in there? Okay. So yeah, 5.5 is the speed she finishes. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.